Hi, everyone, and welcome to this episode of Crowded Beaker Solves. Today, we're continuing our journey into mole conversions by turning a mass of a sample into the number of particles of a sample, in this case, the number of atoms in a sample. So let's take a look. I actually have a sample of copper here, and you can see that it has the coppery color. It's kind of knobby looking, weird, irregularly shaped nugget that I have here. But I actually went and put it on the balance, and I found out that it weighs 25.039 grams, and that's copper. So, what if I was interested in how many atoms of copper were actually in this thing? Luckily for us, we have a way to calculate that without much effort. And so, what we're going to be doing is starting with the 25 grams that we have, 25.039 grams, and make sure to note that it's copper. And what we know as chemists is that we can take a mass like this, and we can't go directly into particles, but we have to figure out first how many moles of particles that we actually have. And so we're going to do it just like the way we did it in some of our other videos. And we're going to say, all right, 1 mole of copper is 65.453 grams of copper. That came from the periodic table. And if you have to look it up, that's fine. Nobody's judging. Go ahead and look it up. So you get your dividing by this, you'll get the number of moles of copper that are in this actual sample. But I don't want to stop there. I want to know how many atoms are actually in there. And so I'm going to actually not stop here, but keep going. And if I know that I'm going to keep going, I can simply add another conversion factor. And because I'm at this point in moles, and I want to get rid of moles, I can put that on the bottom. 1 mole of copper. And we've also learned that 1 mole of anything is Avogadro's number, or 6.02 times 10 to the 23rd atoms of that thing. Now I punched it in my calculator, and my calculator gave me this number, 2.3, and then there's a whole bunch of digits. I don't want to put the whole number, bunch of digits. I started with 5, 5, and I only have 3 here, so I'm just going to keep 3. 2.30 times 10 to the 23rd atoms of copper. So, to the best of my ability, with a quick little calculation, I have a 2.30 times 10 to the 23rd atoms of copper in this nugget. And that's really cool that we can actually calculate that and predict how many atoms we actually have. So, it's your turn. So, I will put the next one up there. I actually have another sample I'd like to show you. I actually have a sample of mercury this time. And mercury, if you've never seen it, is a silvery liquid metal. It's actually quite heavy, and so you can see it sloshing around in there. I'm going to use both hands so I don't drop it. And this sample contains just over 30 milliliters of mercury. And I put it on the balance, and it happens to weigh 439.2 grams. So it's your turn. Take a moment and see if you can calculate or predict how many atoms of mercury are in that sample. Feel free to pause the video. Okay, so if you were able to do it and you got an answer of 1.32 times 10 to the 24th atoms of mercury, then congratulations, you're doing well, and that was a great effort. And so we have been able to predict, again, by taking the mass, divide by its molar mass, which in this case is 200.59, again, multiply by Avogadro's number, and we get 1.32 times 10 to the 24th atoms in this little jar. And yeah, that's pretty heavy, but really cool to look at. So there you have it, unit conversions from mass to particles. If you have any suggestions of problems you'd like me to include on this channel, feel free to send that to me. Otherwise, happy solving and have a great